In this video, we will be presenting Ozomax's patented Advanced Oxidation Process, or AOP process. We'll be visiting a mobile water treatment plant that was designed and built to treat FRAC effluent. However, the same water treatment plant could be used to treat produce water, slaughterhouse effluent, food processing plant effluent, paint effluent, electroplating effluent, textile water, basically any type of effluent that contains organic and inorganic chemical oxygen demand and TSS, or dissolved solids. The process will remove total dissolved solids, heavy metals, scale-forming elements, microorganisms, hydrocarbons, and in some cases total dissolved solids depending on the analysis. The container is separated into two parts. The part that we're entering now is the ozone generation part. Here we see the back of the ozone generator, which is equipped with an air conditioning system, such that the performance of the ozonator is independent of the ambient temperature and humidity located at the treatment site. This system allows the internal temperature and humidity to be controlled such that the ozone production is optimal. Let's see the front of the ozone generator. Here is the control panel. As you can see, it is equipped with a number of controls which allows the operator to control the amount of ozone being produced depending on the analysis of the effluent he is treating. So the ozone output can be easily varied as desired by the operator. Let's take a look inside. Here we see that the ozone generator, this specific model is a 32HDHF, which produces 640 grams per hour from oxygen feed. What I'd like you to notice is that there exists an internal redundancy to the system. Here we have the corona lamps, and here we have the power supplies. And we have several of them throughout the ozone generator. In this specific case, we have 16 lamps and 16 power supplies on this side, and we have the same thing on the other side of the enclosure. This allows for very reliable performance of the ozone generator, as it, should something happen, the chances that 100% of the ozone production capacity will be lost are very, very slim. Once the ozone is produced, it is directed to the other section of the container, which is basically the water treatment section. Before we leave this area, though, I'd like you just to take a look at the compressors and the oxygen concentrators that provide concentrated oxygen to the ozone generator. The reason why we use oxygen as feed is that when we use oxygen feed as opposed to air feed, the ozone production capacity of the same ozone generator doubles. And the concentration of ozone produced is much higher, which facilitates greatly the mass transfer of ozone from the gas phase to the water phase. Speaking of the water phase now, let's go over to the water section of the ozone generator, which begins with our electrocatalytic reactor. Once the ozone produced, it's directed to this reactor here, which contains a series of electrodes which have two functions. The first function is that it allows the conversion of the ozone to more highly reactive entities such as hydroxyl radicals. And the second function is that it allows the separation of the solids found in the effluent from the liquid. So we have simultaneous oxidation and separation of the water. So the raw water enters through the piping here and meets the ozone and the other oxidants, which work to reduce the COD levels and also separate the suspended solids from the liquid phase. Once that happens, the water enters the static mixer where we inject a combination of coagulants and flocculants, or one of the two as the case may be. Depending on the effluent, we can adjust the recipe. And then this enters the dissolved air flotation clarifier. This clarifier allows then the flocculated, coagulated solids to be separated from the water. The solids are evacuated from the container using a sludge pump, where further dewatering can happen outside. And the clarified water enters this holding tank. Now this holding tank it contains a submersible pump which directs the water into a series of filters to remove fine particles and also to remove residual ozone. And in this specific case, since we're treating FRAC water, there is some degree of salinity to the water, and so we are using here a reverse osmosis unit to remove the salt from the water. And here we have the final treatment tank. So basically that gives you an overview of Ozomax's patented advanced oxidation technology. The technology consists of two things, basically. The first patented technology is the ozone production technology itself. And then the second part of the story is the combination of ozone in our electrocatalytic reactor to convert ozone into more highly oxidative species such as hydroxyl radicals. And this occurs under very special conditions using electrodes that are powered by, here in this case, we have a power supply which produces 24 volts DC and up to 2000 amps. And this is also very flexible. We can adjust the power levels depending on the effluent and the flow rates that we are treating. So I hope you've enjoyed this video. I hope that you have a better understanding of Ozomax's advanced oxidation process. For any inquiries, please don't hesitate to contact us at engineering@ozomax.com, and please visit our website for case studies and more information. Thank you.